A programmable logic controller, or PLC, is a small industrial computer engineered for supervising equipment and processes in industrial settings from one central location. In other terms, it is the driving force behind most automated control systems. Since a PLC is a device rather than a person, it cannot think itself to decide. Therefore, how does a PLC carry out actions? A PLC requires programming in a particular language, followed by downloading the program directly into the PLC CPU to function correctly. Under the IEC section 61131-3 standard, there are 5 programming languages utilized for different PLC hardware platforms, namely ladder diagram, LD, function block diagram, FBD, sequential function charts, SFC, structure text, ST, and instruction list, IL. Each language belongs to one of 2 groups, graphical or textual. Graphical languages are designed with visuals, while textual ones rely on written text. In this video, part 1 of the PLC programming languages tutorial, we will cover the essential features of ladder diagram and function block diagram languages. You will gain an understanding of their core structure, advantages, disadvantages, and the scenarios in which they are most suitable. Ladder diagram serves as a graphical top-level PLC programming language. The ladder diagram is the initial programming language for PLCs, evolving naturally due to its close resemblance to electrical relay circuit schematics. Before PLCs were introduced for automation, factories commonly relied on relay-based control systems, which used physical components like mechanical relays and switches to manage tasks. The internal logic of the ladder diagram supersedes traditional hardwired relay controls, except for the devices requiring electrical signals for activation. A ladder diagram is arranged as horizontal lines known as rungs, with 2 vertical bars at either end called power rails. The left rail represents the live or hot rail and the right is neutral, creating a ladder-like design that explains the origin of its name. The input instructions, called contacts, are located on the left of each rung and control the logical flow from the power rail through the rung. The right side features output instructions known as coils, responsible for toggling physical outputs between on and off states. The reading direction for an LD program is first from the left side to the right and then downward from the top. Now is the time to discuss the advantages and disadvantages of the ladder diagram. Rungs play a crucial role in structuring the ladder diagram, resulting in a well-organized layout that is both straightforward to follow and easy to read. Ladder logic not only offers a visual representation of control processes, but also continuously monitors and verifies the status of the majority of its instructions. The ladder diagram's capability for online editing enables users to make real-time modifications to the control logic of a running system, all while ensuring that the system continues to operate smoothly without any interruptions. On the other hand, in the ladder diagram, the absence of specific instructions can introduce complexities, potentially making programming operations such as motion control procedures challenging. When dealing with extensive ladder programs, the process of navigating through and following them can become increasingly complex and challenging. Due to the sequential nature of ladder logic execution, time-sensitive tasks might experience delays. Such delays might be an issue for systems that need quick or real-time responses. For systems that manage extensive and complex Boolean logic, ladder diagram emerges as a premier programming language renowned for its precision and suitability in such intricate scenarios. Next, in the PLC programming languages is the function block diagram, also known as FBD, which utilizes a graphical format. FPD relies on standardized blocks whose purpose is to determine the relationship between the input and output statuses. Function blocks sit on a workspace sheet where they are linked to one another through lines of connection. The final result shares similarities with a piping and instrumentation diagram or PNID. It is simple to replicate this type of schematic using a function block diagram. If a PLC program is written on a single sheet, the PLC will process it, starting from the top left and ending at the bottom right. The scan behavior is controlled by connections made between function blocks. If there are multiple sheets, the PLC continuously scans them in sequence by their numbers. Let's now focus on the pros and cons of the FPD language. Navigating the FPD workspace is hassle-free thanks to its user-friendly interface, which simplifies reading and following simple logic. FPD offers the benefit of consolidating various programming lines into single or multiple functional blocks, thus streamlining the design process and enhancing organization. FPD has the additional advantage of enabling outputs from function blocks to be directly linked to the inputs of other blocks or used as feedback without relying on intermediate variables. On the other hand, an extensive amount of screen space is crucial for FPD programming, which is necessary to manage the logic. Programming in FPD can be messy. If blocks are not placed in an organized manner on the sheet, it can quickly become a confusing mess, making it hard to grasp what's happening. As your FPD programming extends, it becomes difficult to trace the logical flow due to the increasing complexity, which can easily lead to losing track of the sequence. FPD works well with continuous process management, repetitive tasks with regular code usage, systems needing motion control, and PID control mechanisms where analog data is continually assessed and outputs regulated to ensure values remain within a designated range. In part 2 of this tutorial, we will explore sequential function charts, structure text, and instruction lists. Part 2 will provide a similar overview, such as discussing the architecture, pros and cons, and ideal use cases to finally help you decide which language to focus on for your learning journey. So stay tuned. Yoo-hoo! Congrats! You have successfully mastered the essentials of ladder diagram and function block diagram PLC programming languages. Great job! We'd love to hear about any unique experiences you have had with LD and FPD PLC programming languages, so share them in the comments. Also, if you found this video helpful, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out of the oven videos. This way, you keep motivating us to produce more informative videos.